Okay. Okay. Good morning. Can you hear me? Uh, Okay. Kinetic chemistry. We're discussing about the rate of chemical reaction. Good. The rate of chemical reaction. What's the meaning of the rate of chemical reaction? The rate of the speed of chemical reaction. I told any chemical reaction always reactants convert to products. This product characteristic totally differ from vary from reactant characteristics. No, it's a chemical conversion actually. Due to chemical conversion, it's converted to products. Okay, I already explained the mechanism of chemical reaction. What happened? Reactant molecule. If you got this type, very simple example. Magnesium ion react with HCl. The same thing I again explained the mechanism of chemical reaction, right? HCl, then what are the products? Magnesium chloride, MgCl2 plus hydrogen gas, hydrogen release. If you want to balance this equation, you can add 2 chlorine and 2 hydrogen. 2. Okay, this is a balanced chemical equation of the magnesium and HCl reaction. HCl is acid, magnesium is a metal, magnesium chloride, it's a mineral, right? It's a mineral, no acid or base. And release hydrogen gas. It's a gas. Magnesium chloride is a solid, the physical state. Hydrogen is gas. HCl is solid. Sorry, magnesium solid. HCl is aqueous solution. Aqueous solution. AQ mean water diluted solution, water mixed solution, water dissolved solution. Then, okay, how to convert this magnesium and HCl into magnesium chloride and hydrogen? This is the mechanism. Okay, now I think now you have full idea. Okay, what happened? Think they are the magnesium molecule, right? Magnesium molecule. This is a HCl molecule. HCl molecule. Hydrogen and chlorine. Hydrogen and chlorine, right? HCl. It's a compound, not molecule, right? It's compound. They have bond already. මෙයාගේ bonds තියෙනවා මෙතන. Atomic bonds, covalent bonds. It's a covalent bond. Hydrogen and chlorine. Okay, however, they have some bonds between hydrogen and chlorine, right? And it's 2HCl. තව HCl එකක් එනවා මෙතෙන්ට. 2HCl, right? H and chlorine, they also have bonds, right? Okay, now what happened? This molecule collide with this both compound, right? Collide, and they are already available bonds break down. Already, actually, this is not the way. Collide with proper orientation. Sorry, not hydrogen side. Collide with monocyte. Collide with chlorine side. Chlorine side. This is a hydrogen side. This chlorine side, hydrogen side. Right? That is the actual thing. Right? Molecule, reactant molecule collide each other. One magnesium collide with two chlorine atoms. Two chlorine mean two HCl compounds. Two HCl compounds collide, right? Then due to these collisions, there are already available bonds break down. Already available bonds break down. Due to that, this magnesium and chloride, MgCl2, think this is a magnesium molecule and it is combined with, it's forming new bonds between with two chlorine molecule. Okay, that's the meaning of MgCl2. මේ දෙන්නම එක bond එකක් හදා ගන්න. That's called as MgCl2. It's a new compound. This is a product. And this hydrogen, both hydrogen molecules replace this place. And then ion, right? This place, they are the hydrogens H2. It's a gas. Okay, now I think you have full idea, right? Clear? Okay, reactant molecule collide each other and they are already available bonds break down. And due to these collisions, they produce new bonds between reactant molecule. These new compounds are the products. Okay, I told there are three main requirements. Reactant to convert into products. There are three main requirements. What are the requirements? Collisions not enough. They should have proper orientation, right? This is the proper orientation. Then mama කලින් යනපු විදියට this magnesium collide with hydrogen side. Magnesium also plus ions, hydrogen also plus ion. Are they produce bonds? No, it's reflect, not attraction, right? But only chlorine side, if it is collide with proper orientation only, they convert to magnesium chloride, right? The proper orientation is mass, right? It's a main requirement. Okay, then first we discussed what is the requirement collision that you already know. The second requirement is what second requirement? Proper orientation. What is third requirement? They should have sufficient energy. That means this magnesium molecule and chlorine and hydrogen, all molecule, number of reactant molecule, if it is converted into product, they should have energy, sufficient energy level. They should have sufficient energy level up to activation energy or exceed activation energy. Okay, what's the meaning of activation energy? The minimum energy level of reactants, right? These words compulsory. The minimum energy of reactants to participate to the reaction. The minimum energy of reactant molecule. මෙයාලගේ තියෙන minimum energy එක to convert into product or for be an effective collision, right? ඕන විදිහක ලියන්න පුළුවන්. However, the minimum energy of කාගේද reactants ලා. Reactants වල තියෙන minimum energy level එක reaction එකකට participate වෙන්න. or effective collision එකක් වෙන්න. or product එකක් වලට convert වෙන්න. However, any way you can write, you can remember the minimum energy of reactants, right? This is the meaning of activation energy. Okay. Now, we discuss factors affect on the rate of chemical reaction. Factors affect on rate of chemical reaction. What are the factors we discussed last day? Yes. Yeah, temperature and concentration completed. Okay, temperature. I will revise quickly. Temperature. What's the temperature effect? I told any chemical reaction with temperature, increasing the temperature, the rate of chemical reaction increasing, but not all the behavior of all reactions not really same, right? The behaviors are different. If you got it is the temperature and the rate of chemical reaction. If you got normal laboratory reactions, acid base reaction, acid metal reaction, this type normal reactions gradually increase the rate of chemical reaction with temperature. But if you got biochemical reactions, temperature and rate of chemical reaction, okay, this is a behavior after a certain value, after a certain temperature, normally more than 40 Celsius, when it is temperature more than 40 Celsius, again the rate of chemical reaction decreasing. Why? Due to enzymatic inactivation and all system breakdown. Actually, biological systems break down more than 40 Celsius, more than 41, 42 again with the enzymatic activities and other all activities break down. That's why the rate of reaction, biochemical rate of reaction become decrease, right? Gradually decrease again. Okay, but if you got explosion reaction with like combustion inside engine, this is the temperature, the rate of chemical reaction gradually temperature increase, and at a certain level, after a certain level, rapidly increase the rate of chemical reaction within very short time, complete the chemical reaction within less than 1 second. Normally, that's why in first day I told high speed reactions. Okay, they are the nature of high speed reactions, explosive reaction. Okay. Okay, other thing, how to temperature effect to the rate of chemical reaction, how to increase the rate of chemical reaction with temperature, do you remember? How to increase the rate of chemical reaction with temperature? I told two main factors. Two main factors, two main reasons. What are the reasons? What's the first one? How to increase rate of chemical reaction with temperature? What are the reasons? I told two reasons, no? Can you give me summary of first reason? Yeah, when increasing the temperature, when reactant molecule, yeah, kinetic energy increasing, yes. May reactant molecule, they are very simple. With temperature, the molecule kinetic energy increasing. Right? Molecule kinetic energy increasing mean their vibrations increase, therefore their collisions increasing. Collisions increasing. Collisions increasing. Okay, that's why their effective collisions, that means requirement fulfill collisions are increasing. That's why the effective collisions within unit time, ඒ කියන්නේ පොඩි time එකකදී effective collisions amount එක මාර විදියට වැඩි වෙනවා. ඒ කියන්නේ increasing, right? Suddenly increasing within very short time. Okay, that's the reason for increase the rate of chemical reactions, the number of effective collisions. Due to the collisions increasing, number of effective collisions within unit time, within short time, huge number of effective collisions. Okay, that's why within short time it's converted to product suddenly within very short time. Okay, what's the second reason? What's the second reason? With temperature, what's the second reason? Yeah, due to the temperature, their kinetic energy increase. Their kinetic energy increase. Vibration එකත් වැඩි වෙනවා. Samely, at the same time, the kinetic energy increasing. Kinetic energy mean their molecule energy level, molecular energy level, එයාලගේ තියෙන energy level එක වැඩි වෙනවා. As example, think initially 5 joules, 6 joules, 7 joules. It's increasing a certain value. We can't say what is the exact value. Example, අපි හිතමු 6 joule, 7 joule, 8 joule වුණා කියලා. Think the activation energy is 6 joule. 6 joule. Now, initial temperature, less temperature, only 2 molecules can participate for effective collision, can participate to convert products, make products, can participate to the reaction. But if we increase the temperature, now you can see all molecules, then තුනටම participate වෙන්න පුළුවන්. If we increase in the temperature, right? When increase the temperature, molecule kinetic energy increase, then molecular energy level increasing. Molecule energy level increasing. Due to that, number of molecule exceed activation energy. That's the thing. Number of molecule exceed activation energy is increasing. Again, initial temperature, it's exceed activation energy 2. But if we increase the temperature, එතකොට exceed activation energy reactant molecule 3. That's why within short time, within a unit time, effective collision increasing. Okay, that's why, that's the reason for increase the rate of chemical reaction. Okay, that's all about temperature. And I explained the experiment. This experiment you need to remember. If you need to explain the effect of temperature, the rule is other all factors. That mean concentration, catalyst, and physical state, you have to keep constant, both tested. Right? Only change the temperature. Okay, let's move into concentration, our second factor. Second factor. What's the meaning of concentration? Concentration, very simple thing. Okay, what's the meaning of concentration? We already discussed in thermochemistry as well. Concentration, the amount of matters in a unit volume. The amount of matters in a unit volume. If you got a unit volume, 1 cubic meter or 1 cubic centimeter. Amount of matters mean amount of molecule, actually. Number of moles. Hi. Amount of matters. Okay, when increase in the number of amount of matters, that mean amount of molecule in a unit volume. එක volume එකක in a unit volume, when increase in the amount of matters, that means these molecules are very close, right? When increase in number of atoms, number of reactant molecule, it is concentration, mean reactant concentration, not product or catalyst concentration, it's reactant concentration. Now, when increase in the concentration, what happened? The number of molecules within unit volume is increasing. Due to that, these reactant molecules very close to each other. That's the reason for increased rate of chemical reaction. Then their collisions increasing. Increasing the concentration, collisions increase. Therefore, effective collisions increase. Within unit time, number of effective collisions increasing. Okay, this is a reason for increase the rate of chemical reaction. Okay, that's only we discussed in the last class. Do you have any doubt? Everything okay? Siru? Let's move into third factor. Catalyst effect of rate of chemical reaction. Catalyst, third main factor. Catalyst effect of rate of chemical reaction. Okay, catalyst effect of rate of chemical reaction. Okay. Okay. Do you know what are the catalysts? What are the catalysts? Are they chemicals or what are the catalysts? Do you have any idea? Okay, this is the definition. Catalyst are substance. Remember, catalyst are substance. They are chemical substance. Catalyst are chemical substance. Chemical substance. They can increase the rate of chemical reaction or they can change the rate of chemical reaction, right? They can change the rate of chemical reaction. Rate of chemical reaction. The interesting thing is this catalyst not involved for the chemical reaction. That means there is no chemical conversion. Think as example, if you introduce sodium hydroxide as a catalyst for any chemical reaction, sodium hydroxide, caustic soda introduced as a catalyst, right? This catalyst mean මෙයාට පුළුවන් මේ catalyst එකට පුළුවන් to increase the rate of chemical reaction. Increase the chemical reaction, increase the rate of chemical reaction. Speed එක වැඩි කරන්න පුළුවන්. But this catalyst not participate to the reaction. This catalyst not in react with other reactant and convert into product. It's finally at the end of the chemical reaction, this sodium hydroxide, think if you add 10 gram of sodium hydroxide, 10 gram අපිට වෙන් කරගන්න පුළුවන් at the end of chemical reaction. It's not participate to the reaction. If it is participate, it's not a catalyst, it's a reactant. If it is react with another reactant, මේ sodium hydroxide එක අපි දාන catalyst එක මොනවා හරි එක react කරොත්, if it is react with other reactant, it's not a catalyst, it's a reactant, right? These catalysts are special chemical compounds that change the rate of chemical reactions but without participate to the reaction, without any chemical conversion, right? Without undergoing a chemical conversion. Catalysts are substance that increase the rate of chemical reaction. And that way, most catalysts are increasing, but some catalysts decreasing. Rate එක decrease කරන catalyst තියෙනවා. හරි අපි බලමු. Catalyst are substance that increase the rate of chemical reaction without undergoing any permanent chemical change. Without permanent chemical change. ඒ කියන්නේ if you introduce ferrous as a catalyst, ferrous mean iron powder. යකඩ කුඩු කියන්නේ. Iron as a ferrous as a catalyst. End of the reaction, you can separate Ferrous, not ferrous oxide or ferrous hydroxide, not forming. I got, that's the meaning of catalyst. They not permanent chemical change, but physical change is okay. If you introduce the if you introduce magnesium magnesium solid strip into chemical reaction as a catalyst, it's okay to convert into powder, right? But no chemical changes. Powder mean it's still magnesium powder, not magnesium oxide or magnesium hydroxide, right? No any chemical changes. Okay, they are the catalysts. Catalysts are substance that can increase the rate of chemical reaction without participate to the reaction, without any chemical conversions, without any chemical changes. I got. There is no any chemical changes, right? There is no any chemical changes that can only increase the rate of chemical reaction or change the rate of chemical reactions without participate to the reaction. ඒ කියන්නේ අනිත් reactant එක reaction එකක් වෙන්නේ නැහැ. No any chemical conversion. Okay, mainly we can find two types of catalyst in chemical reactions. The first one is homogeneous catalyst. The first one is homogeneous catalyst. Write down the first catalyst types. Homogeneous catalyst. Homogeneous catalyst. The second one is heterogeneous catalyst. Heterogeneous catalyst. Homogeneous catalyst and heterogeneous catalyst. Homogeneous catalyst and heterogeneous catalyst. I told you this catalyst increase the rate of chemical reactions without any chemical changes. But physical changes possible. If you add magnesium solid, it's converted into powder, but still magnesium, right? Magnesium powder una, right? It's physical state changes okay, but no any chemical changes. No any chemical changes. Magnesium දැම්මනම් end of reaction you can collect magnesium, not magnesium oxide or magnesium hydroxide or any different chemical, right? It's not participate to the reaction, but it's not producing any new product, but it's involved and increase the rate of chemical reactions on. ඒක involvement එක තියෙන්නේ increase the rate of reaction. That's the thing. Okay, now what are the homogeneous catalysts? What's the meaning of homogeneous catalyst? Homogeneous. What's the meaning of homogeneous word? Homogeneous. What's the meaning of homogeneous word? The homogeneous කියන්නේ මොනවද? Same state, no? Same state. Okay. Remember, if catalyst and reactant, that's the main thing. Don't write. Make it යන්න catalyst and now මෙහෙම. Don't write this. Okay, think this is reactant. Reactant convert into product. This is a chemical reaction, right? Products. To increase the rate of chemical reaction, we can introduce catalyst. Catalyst. Right? To increase the rate of chemical reaction. Think this reactant physical state is aqueous. Aqueous. Catalyst physical state also aqueous. product chemical state solid. Product chemical state solid. Okay, this type catalyst are the homogeneous catalyst. Homogeneous catalyst means reactant and catalyst, if it is same physical state, they are the homogeneous catalyst, not product. Products only reactants and catalyst. Reactant and catalyst. If reactants and catalyst in the same physical state, this type catalysts are called as homogeneous catalyst. Clear? Okay, then write down. If reactants and catalyst in the same physical state, this type catalyst are called as homogeneous catalyst. Homogeneous catalyst. හරි. ඊට පස්සේ මේක ලියන්න. Reactant and catalyst in the same physical state. If you got solid reactant, add solid catalyst. If you got liquid reactant, add liquid catalyst. Same physical state, same physical state catalyst are same physical state catalyst with reactants, they are the homogeneous catalyst. Complete? Mentally, අද මේක ඉවර කරලා අපි finish කරන්න ඕනේ at least 10-20. Today we can complete the theory part of the kinetic chemistry and Wednesday, is it poe? No poe. Thursday poe. Then Wednesday we can complete the lesson and next month we start the new lesson. Next month we start biology part. After biology 2 lessons, biology 2 lessons mean it's very simple 2 lessons, cell structure, but it's bulk lesson දෙකක් තියෙන්නේ. අපි let's try to complete within 2 months. Within 2 months, if we can complete, yeah, within 2 months complete කරන්න ඕනේ within September and October. Yeah, if we can complete biology part end of October, yeah, other all lessons we can complete end of May. Yes. Okay, complete. Hari. Example. H2O2 hydrogen peroxide. It's a aqueous solution. The breakdown of a then අපි මේ H2O2 solution එකක් aqueous solution එකක් තිබ්බම එයා convert වෙනවා. Normally it is naturally, it can without any catalyst, it convert to oxygen and hydrogen. It's releasing some gas, oxygen and hydrogen, air bubbles. Oxygen and oxygen and water, H2O. Yeah, oxygen and water. This oxygen is a gas, water is liquid. Water is liquid. Okay, now this same chemical reaction we can accelerate, or we can increase the rate by adding sodium hydroxide as a catalyst. The sodium hydroxide also aqueous solution. Then it is homogeneous catalyst. Homogeneous catalyst. Homogeneous catalyst. Okay, can you balance this equation? Okay, how to balance this equation? Oxygen 2, oxygen 2, no, oxygen 3, oxygen 2. You have to add 2 and oxygen 4. Oxygen 4, hydrogen 4 are now balance. Now balance. Okay, second example. Second example. SO2. SO2 is a gas, no? SO2 is a gas. This SO2 gas, sulfur dioxide, react with oxygen gas. React with oxygen gas. And it is converting to මෙයාගෙන් හැදෙනවා SO3 gas. SO3 gas. This chemical reaction we can accelerate or increase the rate of chemical reaction by adding nitric oxide, no, nitrogen monoxide gas as a catalyst, NO as a catalyst. That one also homogeneous catalyst. Homogeneous catalyst, same physical state, reactant, both reactant and catalyst in the same physical state. It's a homogeneous catalyst. Homogeneous catalyst. Okay, can you balance this? May I pull on the balance? Oxygen 4, oxygen 4. Then we have to add 2. Then oxygen 6, sulfur 2. Now it's balanced. Complete and understood homogeneous catalyst? You met? Hi. Let's move into heterogeneous catalyst. Heterogeneous catalyst means now you can understand what's the difference. Heterogeneous means if reactants and products, sorry, catalyst in different physical states, these types catalysts are called as heterogeneous catalyst. Heterogeneous catalyst. Okay, they are the heterogeneous catalyst. Reactants and catalyst in different physical states. Different physical states. Okay. Like this. Reactants, solid state, this product, it's gas or something. Catalyst, liquid, like this. Different physical states. Different physical states. Right. Write down the example. Same example, right? Your syllabus given same example to understand clearly. H2O2, hydrogen peroxide. It's convert into oxygen and water. Oxygen and water, then oxygen, oxygen 4 and hydrogen. Yeah, now it is balanced. Now it is balanced. And how to accelerate this chemical reaction? Now you can introduce MnO2. What are the MnO2? Do you know the name of MnO2? Chemical name of MnO2? MnO2. Yeah, permanganate කියලා කියන that's actual name is manganese oxide. Manganese oxide. If you got KMnO4, KMnO4, it's potassium permanganate. Yes. Yeah, manganese oxide is a solid. Sorry, solid. It's a aqueous solution. Aqueous solution. Oxygen is a gas, water is a liquid. Then it is homogeneous or heterogeneous. It's heterogeneous. Now, different physical states. Physical state is not same, reactant and catalyst. Okay, they are the heterogeneous catalyst. They are the heterogeneous catalyst. Hari. තව එකක් ගමු. Same example as previous. SO2 plus oxygen, then it is converted to SO3 gas. Now, this chemical reaction, SO2 is a gas, oxygen also gas, SO3 also gas. All are reactants and products, all gases. Now, how to balance this? SO3 you have to add 2, oxygen 4 and 2. Now it is balanced. Now, the same chemical reaction you can accelerate or increase the rate of chemical reaction by adding V2O5. Yeah, V2O5, it's a solid. What's the meaning of V2O5? What's the name of that? Do you know? V2O5. V2O5. We mean vanadium. Vanadium V2O තිබ්බනම් vanadium oxide, right? V2O5 mean vanadium pentoxide. Yeah, we mean vanadium, Dinul. Yeah, very good. 5 O's mean pentoxide. Yeah, vanadium pentoxide. මේ වගේ නම් ලියා ගන්න. It is manganese oxide. Manganese oxide මෙයා vanadium pentoxide, manganese oxide. Vanadium pentoxide, manganese oxide. Both are solids. They are heterogeneous catalysts. Not always heterogeneous catalyst solid. Okay, it's different from reactant. If you got solid catalyst, solid reactant, and add liquid catalyst, it's heterogeneous, right? Any physical state you can use, but different physical state with reactants. Okay. Okay. The next one, practically expression the activity of catalyst effect to the rate of chemical reaction. Okay. Practically we have to explain now. Now it's very simple, practical, same as previous. Okay. Okay, it's very simple, practical again. Okay, for the differences for catalyst effect practical, you have to select 3 same size test tubes. 3 same size test tubes. Label as A, B, C and A, B and C. And at same concentration and same volume of HCl solution. Same concentration, same volume of not HCl, H2A, H2O2. H2O2. What are the meaning of H2O2? Hydrogen peroxide. Hydrogen peroxide, apigamo. Same concentration. Same concentration, same volume. Same volume. Hydrogen peroxide. Hydrogen peroxide means H2O2. Hi. Now, okay, this is a practical. It's very simple practical. Hari. If you want, you can introduce a method of it. For more clarification, same water bath. Both all test tubes placed in same water bath. Same water bath. So, water bath. They are water. Right, water. Water. And for first test tube, you have to introduce 10 gram of water. 10 gram of water. 10 gram of water. Second test tube, you have to introduce 10 gram of H2O, not H2O2, sodium hydroxide. Sodium hydroxide, aqueous solution. Aqueous solution. For next test tube, you have to introduce 10 gram of MnO2. MnO2 solid. 10 grams. Okay, this is a practical, very simple. First draw this, I will explain. Okay, complete. Hari. Okay. Okay, now I have select three same size test tubes and at same concentration, same volume of H2O to hydrogen peroxide solution. And for first test tube, add 10 gram of water. 10 gram of water. What is this? What's the purpose of adding water? හරි එකක් බලමු පස්සේ first එකට මේ second මේ test tube same volume of hydrogen peroxide and adding 10 gram of sodium hydroxide. Now H2O to hydrogen peroxide aqueous, sodium hydroxide also aqueous. Then what is this? Homogeneous catalyst or heterogeneous catalyst? What is this catalyst? Yeah, homogeneous catalyst. Same physical state. For final test tube, hydrogen peroxide, same concentration, same volume, and adding 10 gram of manganese oxide. What is the type of catalyst? What's the type of catalyst? It's a heterogeneous catalyst. Okay, then what you can get the observation? I told මොනවද අපිට මේකේ observations? What do you think? What are the observations? Okay, now hydrogen peroxide breakdown actually. If we got any aqueous solution, එක අපි aqueous solution එකක් කියන්නේ water එක mix කරාම hydrogen peroxide breakdown, it's converted to water and oxygen. Then oxygen releasing, oxygen bubbles we can observe. Okay, first test tube, A test tube, you can see very normal rate oxygen releasing. Right, slowly release oxygen. Then what's the purpose of adding water? Is it catalyst or not? Water can catalyst එකක්ද? Water. No. Then what's the purpose of adding water into first test tube? Added water to as a control sample, control experiment. Otherwise, otherwise how we can compare the rate? Hari. Make the control as a control sample, right? They are the experiment sample. Okay, but then B test tube, we added catalyst, homogeneous catalyst. Then the air bubbling speed is greater than A. C is a heterogeneous catalyst. Then this is a more speed one. Normally heterogeneous the rate of reaction is compared to homogeneous catalyst, it's greater. Like this. Okay. Okay, draw the observations as observations. The air bubbling is the observation due to release oxygen. A test tube no used any catalyst, then it is slowly release oxygen molecule, oxygen gas. Okay, write down the first point. Select same size 3 test tubes and label as A, B, C. A, B, and C. A, B, and C. Second point. All test tube fill with same concentration H2O2 solution with same volume. Right. Correct second point. Finish. Third point. A test tube, sorry, 10 gram of water. Distilled water क्या था? Distilled water or deionized water. Distilled water add into A test tube and 10 gram of sodium hydroxide solution add into B test tube and 10 gram of manganese oxide powder. It's a powder, right? Or solid. C test tube. හරි ඔය ටික ඇඩ් කරගන්න තියෙන්නේ. Okay, final step. Get the observation. Sorry. Place all test tube in a same water bath and get the observation. Get the observation of air bubbling speed Air release speed. Air release speed. Space ivarai. Do you have more space? We need 2 more rules. තියෙනව නේද? හරි තියෙනවා. Yeah. Then observation. Observation. Getting her ලියන්න observation. 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 B and C test tube air bubbling speed greater than A test tube. A test tube. Okay. මේ යටින් ලියන්න ඕනේ මේක conclusion. 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 A test tube reaction slow no catalyst added. No catalyst added. Right? A test tube, the reaction slow, no catalyst added. That's the reason, right? No any catalyst used. B test tube, it's speed than A, what's a catalyst? Homogeneous catalyst. Homogeneous catalyst. Added homogeneous catalyst. C test tube, speed greater than A and B both. Speed greater than A and the reason heterogeneous catalyst. Heterogeneous catalyst. Okay, that's the final conclusion. Hari, thakara liya. Are you clear? A test tube, it is very slow. The reason no catalyst used, water is not a catalyst. Water is not a catalyst. Therefore, it's very slow. B test tube, its speed greater than a test tube. The reason used homogeneous catalyst. If you use heterogeneous catalyst, it's more speed greater than all test tubes. Complete. Make okay the document to learn. Okay, simple thing. We have two more factors. Hurry. Explain the effect of catalyst to the rate of chemical reactions according to the basic concept of kinetic chemistry. Okay. Now, you know how to increase the rate of chemical reaction due to increased temperature. How to increase rate of chemical reaction due to increase the reactant concentration. Now, how to increase the rate of chemical reaction due to adding catalyst homogeneous to heterogeneous catalyst? What happened? Make it. Remember, this is the very basic things. Very basic level. Make it. Now, think there is a chemical reaction with reactant molecule. Think it is A, B, C, and D. Their energy levels 7 joules, 8 joules, 9 joules, 10 joules. Right? This chemical reaction, think to participate to this chemical reaction, the minimum energy requirement, that means activation energies, the activation energy for this chemical reaction is 9 joules. 9 joules. 9 joules. Then who can participate to the reaction? Only C and D can participate to the reaction by effective collision. A and B cannot participate. Are you okay? Yeah, that's a basic theory. But when it is without catalyst, okay, without catalyst, this is the story. But when we introduce catalyst, අපි catalyst එකක් දුන්නාම මොකද වෙන්නේ? When we introduce catalyst, the activation energy decrease. Activation energy decreasing means, think activation energy 8 joules now. Activation energy initially 9 joule without catalyst, it's dropped up to 8 joules when we introduce catalyst. Right, that's the story. When we introduce catalyst, it's 8 joules now. Now what happened? B also can participate to the reaction. Then actually by this catalyst, what happened? Decrease the activation energy for any chemical reaction. Kalinkare by temperature increase the energy level of reactants. Initially by temperature, yeah, this one by temperature increase the energy level of reactants. Then exceed the number of molecule exceed the activation energy is increasing. Right? It's a different story. But when we introduce catalyst, the activation energy decrease. Therefore, number of molecule exceed the activation energy is increasing. Right? This is the story. I will explain again. Initially, without catalyst, think the activation energy 9 joule for a particular chemical reaction. But when we introduce catalyst, what they doing? They decrease the rate, decrease the required minimum energy. That means activation energy decrease. මෙයා අඩු කරලා දෙනවා. When we introduce catalyst. Okay, that's the main purpose of catalyst, adding catalyst to any chemical reaction, homogeneous or heterogeneous, all catalysts decrease the activation energy. When decreasing the activation energy, number of molecules exceed the activation energy. මෙයාට වඩා වැඩි number of molecules මොකද වෙන්නේ? ඉබේම වැඩි වෙනවා. මොකද මෙයා අඩු වෙද්දි මෙයාට වඩා වැඩි තියෙන වැඩි වෙනවනේ. එයාලගේ energy වැඩි වෙන්නේ නැහැ. Energy same, reactant molecule energy same, but number of molecule exceed this level is increasing. That's the reason to increase the effective collisions within short time. Are you clear? Any doubt? Dinod? This is the purpose of Yumet-Tharaka. The catalyst job is decrease the activation energy for a particular reaction. Then activation energy decreasing mean number of molecule exceed the activation energy is increasing. ඒ කියන්නේ sufficient energy තියෙන number of molecules වැඩි වෙනවා. Increase the number of molecule with sufficient energy. That's the reason for increase the rate of chemical reaction. Okay, the other thing, when make a හැමදාම exam එකේ අහන. All past papers you can find this graph, right? Okay, if you got this is a reaction coordinate. Or reaction progress. This is the energy. Okay, what do you think if it is exothermic reaction? Who has great energy level? Reactant or product? Exothermic reaction, target energy ready. If it is exothermic reaction, who has greater energy? Reactants or products? Target. Yeah, the reactant energy greater than products. Reactant energy greater than products. Right, good. Now think they are the reactants, they are the products. Reactants and products. Reactants and products. Energy levels, right? Methane products. Product energy level less than reactant due to some energy loss. It is exothermic reaction. Exothermic reaction. Exothermic reaction. Exothermic reaction. Okay, if you got this reaction without catalyst, this is a path of reaction. This is a path of reaction. ඊට වඩා මෙහෙමත් ගන්න පුළුවන්. Yeah, this is a path of reaction. Yeah, this is a path of reaction. Path of reaction means this is activation energy. Activation energy. මෙන්න මෙතනට ගිහින් තමා if any molecule, this is the initial reactant energy level, right? If any molecule to convert into product, it can make a නිකන් හිතන්න slope එකක් කියලා. Think it as a slope or mountain. This reactant molecule should have energy level up to this level. මෙන්න මෙතන think energy level. Understand? Okay, it's very very important thing. Think initial reactant molecule, then product අපි හිතමු මෙතන 20 joules. It's 60 joules. Think it is 100. the activation energy for this reaction is 100 joule. Reactant molecule initially 60, right? If any molecule to participate to the reaction, they need to increase due to kinetic energy. Due to kinetic energy, මෙන්න මේ climb එක යන්න පුළුවන් නම් විතරයි they can convert into product. If they have 100 joules, 100 is example. These values are example, right? Okay, this is a graph without catalyst, without catalyst, without catalyst, without catalyst, without catalyst. Okay, when we introduce catalyst, what happened? These, when we introduce any catalyst to chemical reactions, it's producing new path with less activation energy, with less activation energy. This with catalyst, with catalyst, with catalyst, with catalyst. If you got the activation energy means the reactant molecule minimum energy level. Therefore, මෙන්න මෙහෙම මම දාන්නම්. Think it is E1, මෙයා E2, right? E1 mean activation energy without catalyst. Local activation energy greater without catalyst. Without catalyst. E2 means less activation energy with catalyst. It is less activation energy. Actually, that's the purpose of adding catalyst. Produce new path, new progress with less activation energy. Then more number of molecules can participate in the reaction due to less activation energy. I got? Give me a second. Oh, sorry. Okay, now I told you. Okay, this is the path of reaction without any catalyst. If we introduce catalyst, what happens? It form a new path with less activation energy. Less activation energy. It is activation energy. The E1 mean is total height from reactants, because activation energy means the minimum energy of reactants, right? This is the activation energy without catalyst. E2 mean activation energy with catalyst after adding catalyst. Okay, this is for exothermic reaction. Now can you imagine the same concept to endothermic reaction? Endothermic reaction, the difference is, for endothermic reactions, the difference is, okay, endothermic reaction, then who has great energy, reactants or products? Yeah, product energy greater than reactants. Product energy greater than reactants. Okay, they are the reactants and products. Reactants and products. Okay, now reactants, this is energy, and reaction coordinate. Reaction coordinate. Okay, reactants convert to products like this. Reactants convert to product like this. Okay, this path for without catalyst. Without catalyst, this much energy required. මේ තරම් activation energy එකක් ඕනේ. Then this is the activation energy without catalyst. Really understand. This is the activation energy. Activation energy එක always ගන්න කොහෙන්ද? Reactant. That's why I told you the activation energy means minimum energy level of reactants. Reactants. It's E1 without catalyst. E1. If we introduce a catalyst, what happens? It may form a new path with less activation energy. New path with less activation energy. Okay, that's why the number of molecule exceed the activation energy is increased. It's E2. E2. Then E1, same as E1 mean activation energy without catalyst. E2 mean activation energy with catalyst. Activation energy with catalyst. Okay, are you clear? This is the changes due to changes of reactions due to adding catalyst. May අපි මෙතන ලිව්වේ activation, sorry, the path of without catalyst. Without catalyst. Without catalyst. This is for with catalyst. The path of with catalyst. Hi. Okay, now let's move into this part. Okay, explain the effect of catalyst to the rate of chemical reaction according to the basic concept. The effect of catalyst. Write down. When introduce a catalyst, into any chemical reaction, it's form a new path of chemical reaction with less activation energy. With less activation energy. With less activation energy. Then number of molecule exceed the activation energy, exceed the activation energy, is increasing. This is the reason for increase the rate of chemical reaction with catalyst. Now you have very limited space. දැන් මෙතන අඳින්න තියෙන්නේ මේ graph දෙක. I complete this. Dule. It's form a new path with less activation energy. That's therefore number of molecule exceed activation energy increasing. Due to that effective collisions increasing, ඒක නිසා තමයි rate of reaction is increasing. හරි. Can you draw this? ඉඩ තියෙයිද? Or if you don't have space, draw a separate paper and attach to the tube. ඕන විදිහක් කරන්න මේ දෙක තමයි ඔතෙන්ට එන්න ඕන. This is for exothermic reaction, this is for endothermic reaction. Endothermic වල product වල energy වැඩි. Endothermic reaction. Endothermic. Same story, right? The only difference is the reactant product energy levels, energy changes. Endothermic reaction. Okay, finish. The difference is same thing, right? Same thing. When we add catalyst for any chemical reactions, it form a new path with less activation energy. Less activation energy. Then what happened? The number of reactant molecule exceed the activation energy is increasing. ඒ කියන්නේ ඒ level එකට වඩා වැඩි number of molecules amount එක වැඩි වෙනවා. Right? Due to that, effective collisions increase, the rate of chemical reaction increase, right? Okay, that's a graph to show the less form new path when we adding catalyst, right? The difference is if you got exothermic reaction, reactant energy greater than product. If you got endothermic reaction, product energy greater than reactants. Hari, do you have any doubt up to now? We discussed up to catalyst today. You met today? Okay. Okay, then we have only one factor. The final factor, the contact surface area. Contact surface area and its effects. Okay, and next Wednesday we start our main calculation part, the rate of chemical reaction calculation. That's the most important session. Taking question එකක් අනිවාර්යෙන් වෙනවා. These factors also very important, but these factors, it is theory, you can understand very simply. But this calculation part bit hard, this expression development and their variations, it's bit hard. And you should have clear idea. Same as thermochemistry. Then let's do it Wednesday. Now I have to go to a session. Okay, then let's do the final part of this lesson this Wednesday, 26th, final week. Okay, goodbye. Good night.